Hello and welcome to another episode of R&D Check-In, today with José Silva, our Chief Architect.
Hello.
Hello, and let's start from a complete beginning. How did you get into engineering and why?
Every time I went into contact with a computer, it just became, I became obsessed about it. And so naturally, as I progressed through my school system all the way out to university, I just kept following it because I couldn't remember any other thing that I would be happy doing. So I didn't think it was a deliberate choice. I just followed the passion, and this is where I left off. So it's interesting because all the way down to university, I actually started being first a web designer. I loved the visual part of it. I'm a visual learner, web designer, web developer, and I slowly moved on to the back end. But because I went through all of that, this is where then I realized, I can't be funneled in one of these. So I started pursuing the architecture.
Well, now you're Chief Architect, which is, let's say, the most senior role within the R&D organization. You don't work with cement, which...
No, I don't work with cement.
Sometimes you get those questions.
Yeah.
But you were before principal, as I recall.
Yes.
So how did that shift happen, and was it something that you pursued kind of deliberately, or did it come naturally?
It came naturally. I started working in one of the divisions as principal engineer, but my role was always to connect with the other divisions. So it just became natural that function sits at a slightly higher level. And so instead of reporting to a VP, reporting directly to CPTO, and continue on doing that work. So it was just happened naturally, not something that I directly pursued.
And you oversee a thing called AMET.
Yes.
Many have heard this abbreviation, but maybe not everybody knows exactly what it means. So can you tell us a couple of words about it?
So in Mews, we don't have a traditional architecture function. What I mean by this is we don't have an architecture team that sits somewhere and then works with the rest of the teams. What we do have is an architecture practice. So the idea there is that we have strong representatives, strong technical leaders from each division that get together into a practice to solve common problems. Because in the end, the success of the teams that they are in drives the success of the staff engineers, and as such drives the success of the architectural function. So AMET is purely just a group of staff engineers that get together to solve common problems, to align needles, to make sure that nobody reinvents the wheel, so that we can pave the way so that when a team needs to do a specific action, we try to make it as simple and as easy as possible. Cognitive overload is a problem. So I tend to say that we try to solve the cognitive tax by taking that away from teams and presenting them with a path where they don't even need to consider all the variables that sit around their value delivery.
So it's not a group of people completely disattached from everywhere. It's people from the teams actually coming together once in a while, I guess, and then coming back to their teams.
Yeah, it has to be. We can't be dissociated by what teams are facing, the problems that they're facing every day, and the plans that they have for the future. We need that input to understand, is there something we could be doing to enable them to be successful? Is there any problem that we foresee that we could start solving so that when the team actually reaches the time where they have to deliver something, everything's already kind of figured out for them. It's not that we replace them in terms of design. They still come up with design. We just try to unblock any problems as early as possible.
So is it something like you're trying to, let's say, see problems 2 steps ahead, or kind of give space to those teams to focus on their things and unlock their potential with some solutions?
Yes, but also bring in learnings from every team and cross-pollinating them across the other staff engineers. So if a team already faced a problem or implemented a complex structure, decision, or system, then why wouldn't the rest of the group take advantage of that so that we can do exactly the same? So we take all the learnings, all the failures, all the successes, and try to cross-pollinate as much as possible so we can bring that information elsewhere. Or else we would just be working in silos. always facing the same problems, always doing the same type of things, reinventing the wheel. There would be no economy of scale. So in the sense where if a team already implemented let's say, a service to send out an email, why would another team build that? So
that staff engineer brings it to your, let's say,
Yes.
meeting, and then the other engineers, oh, okay, that makes sense, let's move it there.
And it does the opposite. So the lessons are learned within the group, then it actually cascades down to the team. So the staff engineer takes all of these learnings back down. So that just prevents teams having to coordinate with multiple teams and learning from multiple teams in parallel. They can just be focused much more on value delivery than this coordination problem. So we pay that coordination tax.
So you mentioned that it's staff engineers, but what type of staff engineer is part of AMET?
So we in Mews we have these two archetypes of staff engineers, what we call the architect staff engineer and the solver. So the difference here is that the focus of the architects is on the cross-functional, while the focus on the solvers is the team itself. So AMET is the collection of all the ones that have the archetype of architect. So what this means is that part of their time is to solve these cross-functional problems. So we have here senior staff engineers, principal engineers, and in some cases, even just senior engineers in it, in case we need their expertise.
And so is that like a set group of people, or it changes to a certain extent?
It's usually stable, but it varies depending on the pressures of the team. So for example, there might be a time or a semester or a quarter where a person simply doesn't have the time to be part of this group. They can opt out of being part of this group and the initiatives in this group, but it's usually a fairly stable one. We do have gaps, but we have almost representation from everyone, for every big logical group within the organization.
But actually, important thing, what does it stand for, AMET?
Architecture, Modernization and Enablement Team.
Okay. And how does the session look like?
It depends on what you mean by session. So first, we have 2 touch points every week. It's kind of it's kind of the heartbeat and try to understand what else should we be focusing on, anything we should be aware, so that we can discuss it as a group, and this includes the entire group, so twice a week. But it's not logical to include 11 or 12 or 13 people in deep conversations about a particular topic. So the practice, which is this touch point, just happens. It's just 2 hours in the week, spread on a Tuesday and on a Thursday. But then we have this whole concept of runway, where if we decide that this is a topic that's worthwhile our time, we delegate that to 2 or 3 staff engineers that then take it over and just do an in-depth session, maybe a workshop on the outside, bring in specialists from outside, so not just us, solve the problem and then bring it back to the discussion, say, okay, this is what we found, this is the decision I think we should pursue, so that we can continue the discussion at the group level.
And I think you call this runways.
Runways, we call them the architecture runways. We have architecture runways for APIs, we have architecture runways for data, for AI, for governance. So these are just ad hoc groups. They don't meet all the time, only when there's something to work on. And it's just to take the cognitive load out of the entire group, because you don't need to have 13 people for every single discussion.
Do you have like some example of a recent recent runway or recent project that was discussed within the runway that we can kind of shed light on?
So let's just say the API runway, for example, was trying to solve the problem of service-to-service authentication within our services. The more we move out a quasi-monolith world into a distributed architecture world, it's quite important that we understand how services should talk to each other and authenticate themselves. So this was a good example. They branched out, they hashed it out, they paved the road. Again, we want to make sure that's as easy as possible for engineers to use that, right? And then they brought it back in. The governance one is another example. We obviously, through time, we make acquisitions. These acquisitions came in with different clouds, different stacks, and that group decided to start meeting so that we can consolidate those accounts into management groups, apply policies to it, and then come back. Though this work is invisible to most people, it just works behind the scene, but it's quite important work for the organization. So these are just two of the many examples we have on a day-to-day life.
And I think you touched on a good point where it seems invisible, let's say, to other people, because some people can say, hey, I have my sprints going on. Why should I care about something that comes from AMET? How would you, let's say, respond to that? I'm not saying this is a real example, but...
I would say that I don't understand the context of care, right? Because if the teams are engaging with their staff engineer, then most likely a lot of what we do is embedded in that part of the conversation, right? We try to make sure that everything is as simple as possible for teams. It's paved, it's thought of, so that when the team needs to pick it up, it's as easy as possible. So I think they see the work in AMET is simply not necessarily obvious that there was a lot of background work on it. I'll reiterate this. It doesn't take any responsibility out of the team. The team still designs their own systems. What we want to do is whatever is outside of that, we want to make it as easy as possible and as safe as possible for the organization, because sometimes not just about the teams, it's about the organization itself. We need to find ways to protect it.
So what are the ways that, let's say, decisions or discussions that were made in AMET reached the product teams, or how they are implemented in real life?
So, and let's maybe talk about the visible decisions, because the invisible decisions are hidden. So there's multiple ways of doing this. So for example, we have, I think of this as multiple level. So you shouldn't be doing the wrong thing. So what we try to do is make sure you prevent teams from, let's say, a blob container public. You simply can't do this. So what happens is the cloud itself protects itself because of that, right? So we try to do this hidden work. But when we make a decision, we tend to publish not only a document that expresses what we want to do, what good looks like, but also how to measure it. And as soon as that is defined, the next question for us is, how can we make this easy? So it's all about talking with platform on building blocks, is trying to, if we can't do this, then we try to come up with these guides and make things easier for teams. Staff engineers then propagate this within the teams as part of their knowledge, or try to, because we're not very perfect in terms of communication. We're still trying to develop that. But that is more or less the sequence. We don't just build documents. We try to build frameworks to measure drift and adoption, but also try to pave that road to make the right way the simplest way.
Mm. Well, I mean, communication is always, I think, the bottleneck of any organization. But one of the things that you now communicate is the weekly incident report, I believe it's called. Why does it belong under chief architect?
So I think the incident, having observability or being able to watch incidents tells you a lot about the ecosystem. So we make long-term plans for scaling, which again is invisible to most of the engineers. We think a lot about resilience, how this would work. And being able to see the patterns of incidents informs us that whatever we had planned will address that. So, or is there any other gap or any other part of the ecosystem that's implemented in a way that could cause us issues? So it makes sense for me to oversee the incidents because I can spot these patterns together with AMET, and we can start working on them as fast as possible so that we can point the teams the right way.
And I think it's already time to bring up AI. It's already 10 minutes. How does it change the way you personally work? And maybe how does it change the way an organization like AMET works?
Well, it changes a lot. Now, decisions are not just for humans, are also for machines. So we need to think about the future where the same guidance that we give humans normally, we make them in a way that they are machine readable so that AI agents can use them. Personally, we try to automate most of what we do and take advantage of AI to spot issues so that we are not necessarily having to check if there's drift or not drift, what's the percentage, what are the teams we need to work with in order to get this down. So there's so much we can do in AI. Personally, I have an AI assistant. It's simply, I'm an IC. I don't have a team. The staff engineers report to the divisions, not to me, which means I need to optimize my time. So this AI has been quite a big help.
And obviously with AI and everything that's been happening recently, the code can be generated way quicker and we can generate way more context. So how much is the architecture, well, the question is no, or the answer is probably obvious that we need the architecture, but how much is it more needed than it was before? Because we have so much generated that it's not just people generating it, but we can have agents running things.
So what AI does, it amplifies what you have. So if you have an unstable foundation, AI will amplify that because it will generate a lot more resource that will hit those, how should I say, weak spots. So governance is essential. Trying to build guardrails or build ways to protect the organization is key to let AI loose. So it changes things dramatically, but I believe architecture is extremely vital to set those boundaries and guardrails.
So you're giving the guardrails now more to the agents than to people?
We have to convert from a human-led to a machine-readable that humans can read type of guidance.
But there should still be humans kind of overseeing or what they've orchestrated?
It depends. It depends on what we mean. So we can use AI to our benefits, doing as much review as possible, doing as much checks as possible against guidance, so we can spot these things early. Now, humans still have a part, but we'll try to use AI to our best advantage so humans can focus on what's valuable.
And on a more human side, I know that outside of work, you write a lot. I don't know, only about technology or about other topics as well?
The space is saturated with technology. I think one of my fascinations, well, let me maybe step back a bit. I think one of the things that I loved about my career is that I managed to find great mentors. And they really changed the way I think. And one of the big gaps in engineering is that we teach engineers on how to think about design, but not how to navigate a world full of subjectivity. So engineering maturity is a passion. I learned a lot from my mentors, and the topics I tend to talk about in my blog are all about that. How to think about these situations, how to develop engineering maturity, how to address a couple of problems. For example, the not challenging decisions from a human perspective is tricky. If you're an engineer, there's a certain level of responsibility to say, I don't think this is the right way to do, right? But think of this as a junior developer. When will that person be safe or assume that it would be safe to be saying no to someone more senior, right? And so it's this type of stories, navigating these complex problems, navigating group dynamics that I'm fascinated about and that I write. It's usually by observation, talking to friends, or in the day-to-day work that I capture these, and I just find these topics fascinating. I have to write about them.
So you mentioned that you had many mentors. Do you mentor yourself?
Yes. Yeah. Yes. I am in Mentor Club online, and I have mentees inside Mews.
Nice. If an engineer is watching, and I hope they are watching, and there is one thing you want them to remember about AMET, what would it be?
We're only successful if you're successful.
Period.
That's it. That there's no point. There's no other goal for us. Obviously, the organization needs to be successful, but if you're successful, the organization is successful. So I always go back to the very basic. If you're not successful, we're not successful.
Well, I think that's a nice way to end this discussion. Jose, thank you very much for joining me. Thank you for coming to Prague. And as always, if you'd like to talk to Jose or me more, you can reach us on Slack if you are in Mews or on LinkedIn. Do you respond to messages on LinkedIn?
Yes.
Yes. So you should get your response. Thank you.
Cheers. It's a pleasure.